right, so we are going to be looking at the example and the practice problem on the relative velocity page. So we're looking at example 3.33. A canoe has a velocity of 0.4 meters per second southeast relative to the Earth. So what we need to do first is we need to identify which pieces of information do we know. So for instance, our non-moving frame, that's going to be the Earth, and our canoe is in a river, so B is going to be the river, and our point or our object is going to be our canoe. So we've identified these. So our 0.4 meters per second at a direction of southeast is going to be the velocity of the canoe relative to the Earth. Okay. The canoe is on a river flowing at 0.5 meters per second east relative to the Earth. Okay, so this is the velocity of the river relative to the Earth. And they want us to then find the velocity of the canoe relative to the river. So canoe relative to river, I'm looking for this one right here. So what we're going to need to do is we're going to need to subtract this one over to the other side. So the canoe relative to the Earth minus the velocity of the river relative to the Earth will give me that value. So I take the top number minus the bottom number. So I have my 0.4 cosine 45 I hat minus 0.5 I hat for the other one. This will give me my x component or my I hat component of my velocity. And then I'm going to have the negative 0.4 sine 45 minus the 0 for my j hat component. All right, and that will give me this velocity I'm looking for. So we'll go ahead, we'll put these components into our calculator, and then we just need to draw them and identify a magnitude direction, because of course they want a magnitude direction. All right, so we get negative 0.22 and negative 0.28 for our two components here. So next what we need to do is we need to go ahead and draw these. So I've got negative 0.22 in the x, negative 0.28 in the y. Now to find the magnitude and the angle, I'm going to need to use my Pythagorean Theorem. So I do my 0.22 and then my 0.28, and I get to square those, take the square root, and I end up with a value of 0.36 meters per second at an angle. And do I now do the inverse tangent of opposite over adjacent, and I get 52 degrees. And the last step I need to do is I need to give this a reference. So this is kind of in the direction of west over here, south over here. So we are in a direction of south of west. All right, so that's that first example. So what we're going to do next is we're going to flip over to 3.38. So let's take a look at this one. Here's a practice one for you. So go ahead, try the practice, pause the video, and then come back and I'll kind of show you some hints if you need hints for solving it. All right, so first step we need to do is we need to identify our frames of reference. So the first one we have is the frame of reference that's stationary. That will be our Earth. Our plane is flying in the air, so B is the air. And then the last, our point, will be our plane. Okay. So now we need to identify what information they've given us, what information we're trying to find. So the wind's blowing at 80 kilometers per hour to the south. So that is the velocity of the air relative to the Earth. They tell us that the plane is moving at 320 kilometers per hour, and that is their air speed. So this is the velocity of the plane relative to our moving frame. That's a B. All right. And then lastly, our plane wants to fly relative to the Earth in a direction due west. So I will be setting up my velocities. Now the funky thing about this one is I have unknowns, but they're not kind of together. It's not like the magnitude and the direction are both unknown. I have a direction missing for one, the magnitude missing for another. But that's okay. The nice thing is I have west and south working for me. So what I can kind of do here is I can set up an x direction equation. And so I have the velocity of the plane relative to the air plus the velocity of the air relative to the Earth will then give me this. So I have to add this here plus my unknowns will give me this for my answer. So in my x direction, I'm going to have the final velocity of the plane. I'll just put a v here. And that will equal 0 plus some value, which is going to be 320. And I kind of have to make an estimate here. And what I'll do is I'll say, hey, if my plane is going to be trying to go west, but it's going to be pushed south, it better be going a little bit north. So it's going to be having to go at this angle. So I can find this component here. So that component would be 320 cosine of whatever that angle is, and it's just going to have a negative sign on it. Okay, so this would be our negative 320 cosine of theta I hat, and then I'll have 320 sine theta j hat in there. All right, so then in my y direction, I will have 0 is equal to negative 80 plus 320 sine of theta. So what I need to do now is I need to go ahead and solve for this theta value right here in my y direction, because that is my only unknown in here. So go ahead, solve for that theta. We get a theta value of 14.5 degrees. So that means our plane is moving at 14.5 degrees to the north of west. Okay. Next, we need to then use that theta value up here and solve for the speed of the plane, and that will be the speed of the plane right here. So that's the plane relative to the ground. So if we plug that theta value in up here, we get a v of 310 kilometers